The purpose of this video is to provide you with an introduction to polynomials. Today, we'll learn to classify polynomials, add polynomials, and subtract polynomials. First off, we're going to define what a polynomial actually is. A polynomial is an expression consisting of one or more terms. But wait a minute, that sounds familiar. Haven't we worked with these types of things before? The answer is yes. We've learned to simplify algebraic expressions in the past. We've even learned how to simplify some nonlinear expressions when we worked with exponential properties. In fact, we've been using vocabulary that directly ties into polynomials all year long. This brings us to our first task. How are polynomials classified? Well, it turns out that polynomials can be classified in two different ways. They can be classified by their number of terms or by degree. Since you already know what terms are, let's start there. When we classify polynomials by term, we use word prefixes, just like the ones you talk about in science class. More specifically, we use the word prefixes that mean 1, 2, and so on. Let's consider an expression containing one term. The word prefix for 1 is mono, so an expression with one term is called a monomial. Do you remember what the word prefix for 2 is? There are actually two of them. There's di and there's bi. Algebra uses the latter, so an expression with two terms is called a binomial. What about a three-term expression? If you said trinomial, you're exactly right. Now, theoretically, we could continue classifying and naming polynomials based on the number of terms, but mathematicians tend to stop here. Why, you may ask? When mathematicians solve certain types of equations, there are special techniques used that involve 1, 2, and 3-term expressions. Therefore, we need names for them. Once we start working with expressions that contain 4 or more terms, the number of terms becomes less important than the degree of the expression. We'll talk about that in a minute. Long story short, we simply call expressions with 4 or more terms polynomials. Poly meaning many. In summary, the word polynomial is used in two ways. First, it's used to classify expressions with 4 or more terms. Second, it's also what I call an umbrella term for any expression, thus the definition at the beginning of this video. That covers classifying polynomials by the number of terms. Let's take a look at classifying polynomials by degree. In general, the degree of a term is the sum of the exponents of the variables of the term. That definition seems complex when it's written out like this, however, the idea is quite simple. Here's an example. Here we have a single term, 6x squared. There is one variable in the term with exponent 2, so the degree is 2. Let's look at another example. The term 7y to the 5th contains a single variable raised to the 5th power, so the degree is 5. Here's an example where the phrase sum used in the definition would apply. Since this term has two variables, we need to find the sum of the exponents of each variable in order to identify the degree. Simply said, we add 2 plus 4. The degree is 6. What about expressions with multiple terms? The degree of a polynomial is the greatest degree of the terms in the polynomial. Here's an example. What's the degree of this binomial? Well, I can see that the degree of the first term is 8, and the degree of the second term is 2. The greatest degree is 8, so this binomial is degree 8. I'll give you one more example before we begin classifying by degree. Take a look at this polynomial. The term with the highest degree is the first term, so the degree of this polynomial is 5. Now that you have a grasp of the degree of a polynomial, we're ready to classify them. This time, I'll organize our vocabulary in a table. I think you may find some familiar terms here. Let's look at a polynomial with degree 0. Remember that the degree of a term is the sum of the exponents of the variable in a term. Since 11 does not contain a variable, the degree is 0. Here's another way to look at it. Getting back to our discussion on vocabulary, do you remember the word for a term without a variable? It's called a constant. I think we've used that before. Here's a binomial of degree 1. The word we use for first-degree polynomials is linear. Sound familiar yet? If the polynomial has degree 2, it's considered to be quadratic. Sometimes students have trouble with this name. Has anyone out there immediately wondered why a second-degree polynomial is called quadratic, even though the prefix quad means 4? If that's you, let me help. Isn't this expression read 3x squared? Do you see what I mean? How many sides does a square have? Let's look at a polynomial of degree 3. There are a lot of terms in this example, but the number of terms doesn't matter. We're focused on degree. Can you guess what a third-degree polynomial is called? It's cubic. If a polynomial has degree 4, it's considered quartic. Now, just like classifying by term, we could theoretically continue naming polynomials by degree. However, it's unnecessary. For any polynomial with degree greater than 4, we simply refer to it by degree. Here's an example of an 8th degree binomial. To generalize this, we say that any polynomial with degree n is considered an nth degree polynomial. We could have a 5th degree polynomial, a 25th degree polynomial, a 21st degree polynomial. The possibilities are endless. That covers polynomial classification. You've learned to classify by the number of terms in the polynomial and its degree. Let's move on. For the remainder of this lesson, we'll be performing operations with polynomials. More specifically, we'll be adding and subtracting them. You'll quickly see that this is familiar territory. To add or subtract polynomials, we first need to eliminate any parentheses using the distributive property. Second, we need to combine like terms. In other words, we're just simplifying the expression. Before we move to a few examples, I want to remind you that we'll be writing all of our final answers in standard form. To clarify, writing an expression in standard form means that we order the terms by degree, from greatest to least. Here we have a few examples of adding and subtracting polynomials. Let's start with number 1. So the original problem for number 1 is the quantity of 6x squared minus x plus 3 plus the quantity of x squared minus 2x minus 7. The first thing we need to do is to eliminate these parentheses. Technically, we use the distributive property. However, when we look at these parentheses, there's nothing but a 1 outside of each of them. So, if we were to distribute the 1 to each term in each quantity, it's not going to change anything. I'm going to bring down this whole expression without the parentheses. Okay, next I need to look for like terms. Remember, like terms have the same variables within the expression raised to the same power. I'm going to look for like terms with highest degree first, since we have to write our final answer in standard form anyway. So I see 6x squared and x squared. So we're doing addition. That will be 7x squared. Next, I see a pair of linear terms. I see negative x and I see negative 2x. I'm going to double underline them so I can tell the difference between each pair of like terms. So negative x minus 2x will give me negative 3x. Finally, I'd see a pair of constants in the expression, so I'm going to combine those constants because those are like terms too. I have positive 3 and a minus 7, a negative 7. That will be negative 4. This expression is completely simplified, so we've successfully added these two trinomials together. Here's my final answer. For number 2, we're also adding two trinomials together, and again, if you take a look, there's nothing but a 1 outside of those parentheses, so I can rewrite this whole expression without the parentheses. I want to look for like terms, and I like to find the terms with the highest degree first. Look around here, I see an 8x squared, 4x squared, and negative 3x squared. So I'm going to combine those three. 8x squared plus 4x squared is 12x squared, minus 3x squared will be 9x squared. also see that there is a linear term here. However, there's no like term to combine with it. When that happens, we just bring that down. Finally, I see a pair of constants. Those are like terms, so I'm going to combine those. I have a positive 4 and a negative 1. 4 minus 1 will be 3. So my final answer is 9x squared minus 2x plus 3. Let's take a look at two examples with subtraction. The concept is the same. First, we have to eliminate parentheses using distribution. Now, if I take a look at the first trinomial in the original problem, there is a 1 in front of there. That's not going to change anything, just like our past two examples. So I'm going to bring everything down. When I take a look at the polynomial that we're subtracting, I'd have to remember that there is a 1 in front of those parentheses. However, because we are subtracting, we need to think of that as a negative 1. So we will have some distribution to do here. So that negative 1 gets distributed to each of the 4 terms in that polynomial. So I will distribute to the first term. That will be a minus 2x cubed, because I made a negative. It was plus 4x squared, but when I distribute that negative 1, it will now be minus 4x squared. For the third term in that polynomial, when I distribute negative 1, it was negative 3x. When I distribute negative 1, it will be positive 3x. And finally, my last term was plus 1 will be minus 1. Now that my grouping symbols are eliminated via distributive property, I'm going to go through and look for my like terms. Highest degree here is 3. I'm going to find those first. So I have a negative 6x cubed and a negative 2x cubed. That will be negative 8x cubed. Second, I'm going to look for any quadratic terms. That means terms where the exponent is a 2. I see negative 4x squared, and I don't see any like terms with it. So that's going to be brought down with the rest of the problem. Next, I'm looking for linear terms, x to the first power. There is a pair of those. There's a positive 5x and a positive 3x. When I combine those two like terms, I should end up with 8x. So I write plus 8x. I also see constants. There's a negative 3 and a negative 1. I'm going to combine those two. Negative 3 plus negative 1 is negative 4. So my final answer is negative 8x cubed minus 4x squared plus 8x minus 4. All right, in example number 4, we're subtracting two trinomials. First thing I need to do is eliminate those parentheses. I can rewrite the first trinomial without changing it because there's nothing but a 1 in front of that quantity. I'm going to have to distribute that negative 1 for my second trinomial. Okay, now that we've eliminated grouping symbols, we're going to go ahead and combine like terms. I see that the highest degree in this expression is 2, so I'm going to combine my quadratic terms first. I see a negative 8x squared, highlight it this time, a negative 8x squared and a positive 8x squared. Those are opposites, so they're actually going to eliminate one another. Next, I see linear terms. There's a 12x and a 3x. That will be 15x. And my constants. Positive 6 and negative 4. When I combine those, I will get 2. Okay, I want you to take a look at number 5, pause the video, and see what you can do. All right, let's see how you did. Your final answer should have been negative 2x squared plus 14x minus 4. Our final example includes a little bit of geometry. The directions state that we need to write an expression for the perimeter of the rectangle. Here we have a rectangle, and I can see that the length and the width are represented by a binomial and a monomial. Keep in mind that perimeter for any rectangle is equal to 2 times the length plus 2 times the width. So we need to substitute our two expressions, one at a time, into that formula. So perimeter here would be 2 times the quantity of 3x minus 4 plus 2 times 5x. First thing I'm going to do is to distribute. So I will have 6x minus 8 plus 10x. Next I'm going to combine like terms. 6x and 10x is 16x. Bring down the constant term. So the expression representing the perimeter for this rectangle is 16x minus 8. Thanks for watching. If you like this video, please remember to like and subscribe. If you have any questions or suggestions for another video, let me know in the comments below.